Hello, and welcome to this ISA Global Cybersecurity Alliance webinar. My name is Matthew, and I will be your Global Spec moderator, and I want to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading Presentation in the upper left is the primary window for today's session. Just to the right of the main presentation window is the Speaker Bio window with background information on today's presenter. And just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed into the queue to address when we get to the Q&A session. At the bottom of your screen, you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with a description of the button's function. Now I would like to introduce today's presenter, Hal Thomas. Hal Thomas is a self-employed consultant at HWT Consulting, LLC. He is formerly a Process Safety Engineering Associate at Air Products for over 36 years. He received a Bachelor of Science in Mechanical Engineering from Bucknell University, is a registered professional engineer in Pennsylvania, and is a certified functional safety expert. Prior to becoming a process safety engineer and being involved in cybersecurity for control systems, he was a process control engineer. Hal has participated in several industry initiatives involving the Center for Chemical Process Safety, ISA 84 and ISA 99. He currently participates in ISA 84 technical report working groups and co-chairs WG9, responsible for TR 88.00.09, cybersecurity related to the safety lifecycle, as well as participating in a number of ISA 99 working groups and co-chairing WG7, which is intended to address the intersection of security and safety. During his career, he has authored and co-authored a number of papers dealing with aspects of risk assessment, including cybersecurity. Hal, welcome to today's event. And with that, I will pass things along to you to get started.
Thank you, Matt. Today, we're going to be talking about cybersecurity risk assessment. And the foundation we're going to use is ANSI/ISA 62443, Security for Industrial Automation and Control Systems, Part 3-2, titled Security Risk Assessment for System Design. Start out, let's talk about the rationale for actually performing cybersecurity risk assessment. When 62443 3-2 was developed, they took a look at control systems and what was available in IT technology, and they concluded that what IT was concerned with were not the kind of things that, if you will, operational technology is concerned with. Whenever you have control systems, you're dealing with things that actually control hardware to produce objects, and the kind of risk that you're dealing with can extend to safety, including injuries, fatalities. You've got your financial concerns from equipment damage and business interruption, as well as environmental potential issues, none of which the IT folks tend to really think about or are concerned with. So when we're dealing with risk assessment, we're really dealing with OT, operational technology, where we're not only looking at the control system network, but also the controllers, all your hardware, all the way down to level 0 in the Purdue reference diagram. So let's just focus on why is it important to conduct cybersecurity risk assessments when we're dealing with control systems. As I said on the previous slide, we're not really concerned with data privacy so much, really concerned with those types of risks that transcend what the traditional IT kind of data confidentiality is concerned with. You may have heard the term IT-OT convergence. That tends to be a term that a lot of control engineers on the OT side really dislike. While it's true that both OT and IT are dealing with the same technology, their applications, their missions, what is important to them, that's really what matters, and those things are very, very different. The last thing I want to talk about on this slide is that many companies actually have an existing risk assessment work process within their companies. That's certainly true in the process industry where I have most of my experience, but it's also true in other industries like transportation and power. So those work processes are already in place, and cybersecurity simply becomes another contribution to the potential risk that the type of risk that they've always been concerned with. And as a result, we should really consider cybersecurity risk assessment as an extension to existing work processes and try to integrate that into the overall work process. So let's take a look at a couple different definitions for risk. The definition that's directly out of 62443-3-2 is expectation of loss expressed as the likelihood that a particular threat will exploit a particular vulnerability with a particular consequence. That's fine for cybersecurity, and that can be fairly broad. Another definition of risk that's actually used in TR 840009 is a measure of human injury, environmental damage, economic loss, loss of intellectual property, or loss of privacy in terms of both the incident likelihood and the magnitude of the loss or injury. Simplified version of this relationship expresses risk as the product of the likelihood and the consequence, i.e. risk equals consequence times likelihood of an incident. That definition is a slight modification to what originally was in the Center for Chemical Process Safety guidelines for developing quantitative safety risk criteria. Now, both of those definitions really started with the concept, the basic formula that risk equals likelihood times consequence. You can modify that for cybersecurity by taking the likelihood as being the likelihood of a successful cyber attack, and let's call that L sub SA. Therefore, simplified risk equation is risk equals L sub SA times consequence. And then you further realize and consider that L sub SA is both a function of the vulnerability V and the threat T. If your system is not vulnerable, then it doesn't matter what the threat is because you'll have zero likelihood. But where you do have vulnerabilities, then you also have to consider your threat. And threat is a function of threat agent skills as well as their motivation and also the target attractiveness. When you take all that into consideration, you can then expand the risk equation to risk equals the vulnerability times the probability of the threat times the consequence. So as we've indicated before, when control systems are involved, the real risks that we're looking for are safety risks, and that can be injuries or fatalities either to workers or the general public. Environmental might be permit violations, or you could extend up to catastrophic environmental events. Financial risk can come from equipment damage, business interruption, quality issues. In some companies using control systems, loss of intellectual property is a significant concern. I think of the pharmaceutical industry, where they've invested a lot of money into their recipes for drugs, as well as, Coke's recipe. It's kind of like famous for, being how secretive it is. Now let's look at the consequence part of risk. This is an excerpt. This was out of 62443-3-2. It documents a range of consequences from lower severity to high severity for some of the different risk categories that one might be concerned with. This is simply an example. I don't know of anyone in the industry who actually uses this exact consequence categorization. The consequence categories that a company uses, it's really the responsibility of an individual company to create their own risk criteria that they're comfortable with. This is simply an example for those companies who wish to dive into this a little bit more. That reference on the slide from the Center for Chemical Process Safety, that was an entire guidelines book devoted to helping educate companies as to developing risk criteria. The other side of the risk equation is likelihood, and once again, this was excerpted out of 62443-3-2. This shows both some qualitative things, and it also shows a frequency-based guidance approach. You take those and you can combine those into a risk matrix. This, once again, this is just an example. But if you have this risk matrix and you have those tables as guidance when you're in a risk assessment, you come up with your vulnerability and your threat. You decide what you feel the threat probability is, the likelihood probability, and the resulting consequence. And at first, you would not consider any safeguards or countermeasures or controls, and that is known as unmitigated risk. That is the worst that can happen if those combinations occur, that likelihood and that consequence. By going to the risk matrix, you can see where red high would indicate that, hey, that's not acceptable. You got to do something to get some risk reduction. If you're down and low in the green, it would be, all right, well, really don't have to worry about this one. Let's move on. So if you end up in the high or the medium high or the medium, and potentially even the medium low, you'd potentially be looking to have additional risk reductions. So now you would consider what safeguards and countermeasures that you have in place. And based upon how much they can lower the risk, you can go from those higher severities down to lower severities to where you would meet your corporate risk, tolerable risk criteria. That's how that is used. And that would be known as the mitigated risk. You're comparing the mitigated risk versus your corporate risk tolerability. Now let's get into the basic work process that's documented within the standard. This is the overall view of the entire work process. You'll notice that the detailed cyber risk assessment is in a sub-process box. So later on, we will expand that particular aspect of the work process into an expanded flowchart. So the first thing is to identify the system under consideration. That's going to be the scope of your hazard review. Then you're expected to do an initial cyber risk assessment, followed by partitioning the system under consideration into zones and conduits, at which point you can ask the question, does my initial risk assessment exceed the tolerable risk? So when you're doing the initial risk assessment, you're basically assuming that the likelihood is 1. You're simply looking at it from a consequence perspective, and if you're too high, then you would go on to perform a detailed cyber risk assessment. If the risk, even without countermeasure safeguards, is low enough, then there wouldn't be a real driving need to expend the time and effort on the detailed cyber risk assessment. Once the risk assessments are complete, they are expected to yield what's known as the cybersecurity requirements specification, and that is intended to provide the foundation, the basis for going and doing your detailed design work. Assuming that recommendations have come out of those risk assessments, they would get turned into action items, and all of the action items need to be addressed. So let's go in through that in a little bit more detail. Let's first talk about the system under consideration. This picture is a sort of a high-level conceptual reference diagram showing the Purdue, using the Purdue model, going from field equipment all the way up to your business enterprise systems. This has been excerpted from the working draft, third edition working draft of ISA TR 84.00.09. You look in here, there's a couple key things. When you're dealing with operational technology, which is your control system and all the supporting things that it needs, that generally will extend all the way from level 0 up into the interface with the IT side of the house. Whether you do or do not have a DMZ, a demilitarized zone, there's always an overlap or an interface between IT and OT. And typically, when you're dealing with control systems, you would be looking at the OT, including the overlap, but you would not be looking at the business enterprise system. The other main point out of this picture, it shows the IIoT, Industrial Internet of Things, and the cloud, and we've also broken that down into the various Purdue levels. And that is to indicate that just because a function is being done in the cloud, if it's performing a function that's associated with the level, that is very much, or should be very much, considered part of the scope, and you should be applying the same requirements to the cloud as you would to the facility itself, to the extent that you're doing facility type stuff within the cloud. So once you've established your scope, you'll do your initial cyber risk assessment. What you're trying to achieve with that, you want to identify the consequences of significance. All right, you're tending to be more focused on the highest level consequences, the high severity consequences, because that is what would provide a basis for initial device security level targets for manufacturers. You should consider that a security level, that's defined as a measure of confidence that the system under configuration, a security zone or conduit, or a device is free from vulnerabilities and functions in the intended manner. So going through the initial risk assessment, you're hoping to be able to assign security level targets, which in turn then is a valuable input to when you partition the architecture into zones and conduits. Also, once you've done that and you've looked at your consequences and you compare it to your risk matrix, you'll figure out whether or not you really need to do a detailed cyber risk assessment. And I would suggest that if you've got a control system performing real work, it's going to be somewhat rare that you would not need to perform a detailed cyber risk assessment. Can't say that it would never happen, but I think it would be rare. Also, going through that exercise, it helps to develop at least the initial part of the cybersecurity requirement specification. Kind of information necessary at this stage to do this type of an assessment: your corporate risk criteria, what are the applicable regulations, standards, and procedures that apply. A key item is to have an asset inventory for your system under consideration, and you also should have those kind of safety risk assessments that came out of methodologies like HAZOP, which stands for Hazard and Operability, FMEA, which stands for Failure Mode and Effect Analysis, or LOPA, Layer of Protection Analysis. There's a lot of other methodologies, but what you're looking for from your traditional safety risk assessment are what are the significant consequences of concern, and when you have those significant consequences of concern, what kind of safeguards do you have to prevent those occurrences, and are those safeguards vulnerable to cyber attack or not? An example of an or not would be a mechanical pressure safety relief valve or a ruptured disc, for instance. That's not really vulnerable to cyber attack. But if you've got something like a burner management system, where you're controlling a fired heater on a boiler, you can have some significant hazards associated with a firebox explosion, and there it's all instrumentation, pure and simple, and it's vulnerable to cyber attack. Typical team makeup for the initial, the facilitator or the team leader, that person needs to be knowledgeable in the methodology. You'd have a process control engineer. Depending upon what industry you're in, it would either be a process safety engineer or a safety engineer if you're in robotics or just manufacturing, and then someone from operations. There's various methodologies that exist out there. There are asset-focused cyber risk assessments. They tend to be my favorite. for what we're trying to accomplish, but there's other ones out there. In the chemical industry, the U.S. federal government has a regulation called Chemical Facility Anti-Terrorism Standard, or CFATS, and they require site vulnerability assessments, and part of that is to do a cybersecurity vulnerability assessment on a site-wide basis. There's also another methodology that's consequence-driven cyber-informed engineering that was developed by Idaho National Labs. All the methodologies that are referenced here on the last slide, we've got actual references that you can use to try to find information on these various methodologies. At the initial risk assessment stage, you're essentially assuming that the likelihood of a successful attack is 1, and just finding out what your worst case issues are. As we indicated, having done the initial risk assessment, it can provide help into partitioning the system under consideration into zones and conduits. The zone has a logical grouping of physical assets. There's a number of ways that you can decide to split up your assets. It could be geographical location, or it could be the criticality of the equipment. Oftentimes, you will split apart safety systems from control systems. Key thing is that when you have a zone, you really want the security requirements for that zone to be common to everything within that zone. So, for instance, if you're concerned about least privilege, to limit access, you don't want to include devices that require everybody and their brother to have access. You'd want to split those into separate zones, for instance. Conduits, those are logical grouping of communication channels that share common security requirements connecting 2 or more zones. And suffice it to say that conduits should have a security level target that's equal to or greater than the security level target of the highest security level target of any zone that it's communicating to. So when you partition it, just to reiterate a couple things we've already said, we want to match the zones to the specific countermeasures needed to support the zone security level targets. And we want to create secure conduits for zone-to-zone communication. Some of the benefits, it supports management of access using least privilege, and it helps to promote defense in depth. It does not provide defense in depth all by itself, but it certainly helps to provide, it enables defense in depth. There is a specific requirement in the standard that says safety-related industrial automated control system assets shall be grouped into zones that are logically or physically separated from zones with non-safety related ISAC assets. However, if they cannot be separated, the entire zone shall be identified as a safety-related zone. The upshot of that is that now all of your control stuff needs to follow the same level of security level targets and rigor that you have for the safety stuff. And that can provide operability issues that operations does not particularly like, but those are some of the things that a company will need to deal with through its risk assessment work process as to how they're going to deal with those kind of things. Also want to note that subzones within zones are permissive and can be very useful. So, for instance, if you have a safety zone with a safety instrumented system, a safety instrumented system is comprised of sensors, logic solvers, and final elements, and workstations to do your configuration of the controllers. The number of people and the type of people who need access to the field equipment is most likely different than the people that you would have that allowing access to the engineering workstation. So even though they're all part of the safety zone, creating subzones that allow some differences in the countermeasures and how you implement those countermeasures can be very useful. Okay, objective of the detailed, assuming we need to do one, we want to identify weaknesses in the design and the supporting procedures. We want to ensure the final design basis has the capability to satisfy corporate risk criteria, and we want it to support the development of that cybersecurity requirements specification at the tail end of the work process. The information for a detailed cyber risk assessment is quite a bit more. This is sort of analogous to process safety information that process safety management regulations require. This would sort of be the equivalent from the cyber side. Your corporate risk criteria, applicable regulations, standards, and procedures, asset inventory for your system under configuration, all the same things as the initial, but now you want to have your engineering drawings. You want to have your zone and conduit drawings, your system architecture documented, your data flow diagrams, what data flows are required, documentation of all remote access requirements as well as any third-party connections that are planned, initial cybersecurity risk assessment report from the initial, safety risk assessment reports, whatever they happen to be, whether it's HAZOP, FMEA, LOPA, et cetera, and what countermeasures are in the scope based upon recognized and generally accepted good engineering practice, or RAGIGEP, and you want to document both the technical and the organizational, which is sort of a fancy way of saying your procedures, because generally your technical countermeasures require organizational procedures, otherwise the technical countermeasures in cyber tend not to be effective. Also, there's a fair amount of vulnerability assessment work that can be done prior to the risk assessment workshop, and that information should be made available. Typical team makeup. Once again, you've got your facilitator, team leader, and once again, that person needs to be knowledgeable in whatever methodology is being used. You might add a scribe. You'll still have your process control engineer. But now, as before, you didn't really need input from IT. Now, you need someone with IT-type skills. We'll call them a network engineer. Preferably, that person is also knowledgeable in control systems, okay, not just IT networks, but a network engineer is very important at this stage. Operations, process, or just simply safety engineer. If you've got plant security, they would want to be involved, and depending upon the industry, either a process or a plant engineer. Okay, so here's the overall detailed risk assessment work process, typically done on either a zone or a conduit. You would first select a zone or a conduit. You'd identify threat vulnerability combinations, and from the threat vulnerability combination, you determine a consequence, determine the unmitigated likelihood that we talked about, which then leads, now that you've got the consequence and you're considering unmitigated likelihood, you can determine your unmitigated risk. That allows you to determine what security level target you're trying to adopt. At that point in time, has the criteria been met? If not, you would identify and evaluate existing countermeasures, reevaluate likelihood and consequence to determine the mitigated risk. Once again, ask the question, is the risk criteria met? If not, make recommendations for additional countermeasures. And then when you get to that point, you ask the question, have all relevant cyber threats been evaluated? If not, you go back and you iterate until you have identified all the threats, and ultimately you ask the question, have all the zones and conduits been evaluated? Once again, you go back and select the next zone. Once you've iteratively gone through this thing, this work process, you get to the point where, yes, we've looked at all of the zones and we've looked at all of the threats within all of the zones. So now it's time to document and communicate the results because we've met our risk criteria. Just wanted to spend a little bit of time on what some of the potential threat sources or agents might be. A threat is any circumstance or event with the potential to adversely impact organizational operations, and this can include mission, functions, image, reputation, and or your organizational assets, including your industrial automated control system. Those threats can emanate both inside a company or a facility or external to the company or facility. Insider threats, some of them are non-malicious. People just make mistakes. You know, somebody clicks on a link that they're not supposed to click on and something bad happens. You can have a disgruntled employee who actively does harm because for whatever reason they're upset, or you could have a malicious insider who is working in collusion with external persons and or organizations. Your external threats can be categorized as nation states, terrorist organizations, criminals. You might have a hacker who's just interested in the thrills of vandalizing something. You can also have activists of various stripes, political hackers, whatever. Depending upon the threat source, that's going to help dictate what their motivations are, so what kind of attacks that they're trying to accomplish, and to some extent it can also help give some insight as to what their skill set might be. It's generally believed that nation states would have, the greatest amount of skills and resources at their disposal to conduct the most insidious type of attacks. But once again, it's just a question of time and money and dedication. And as time goes on, the tools that these people can use are continually getting more sophisticated, making more sophisticated attacks available to a larger variety of external threat agents. Vulnerabilities, can be viewed as a flaw or weakness in a system's design, implementation, or operation and management that could be exploited to violate the system's integrity or security policy. You can identify or measure vulnerabilities a lot of different ways. You can have device vulnerabilities in the hardware. It could be in the firmware. It could be in the software. You might have system capability gaps in the technical capabilities that they have. You may have procedural capability gaps that can be exploited. The IACS network design itself may have vulnerabilities, and when you integrate multiple systems into one big whole via networks, that can introduce even additional vulnerabilities. The only reason I brought this slide back up is that when you identify vulnerabilities, having done vulnerability assessments and having that information available, when you go through this work process, you identify the threat and then you match it up with a vulnerability that you may have already identified. So you're not going through your vulnerability analysis here per se, but you're taking existing vulnerabilities that you know about and matching it up with the threats to walk through this work process. Various methodologies that can be used for detailed cyber risk assessment. There's the cyber PHA methods that sort of have the look and feel of traditional HAZOP methods that are used on the safety side, but are substituting zones for nodes, that kind of thing. There's methodologies that leverage the cyber kill chain that recognizes that an attacker needs to go through a set series of phases in order to be able to effect a successful attack. And by understanding that kill chain and understanding what countermeasures you have, a number of countermeasures will only provide protection against one phase of the kill chain, and some might have more than one. Very few protect against all of the phases. When you actually know what countermeasures are effective against all of the various kill chain phases, that's when you begin to have a much better handle on defense in depth. Sneak path analysis can start looking at the pathways through a network that can be used to conduct an attack on the hardware within your system. You can also use cyber attack trees, which is just a different name for fault tree analysis. You can also use event tree analysis. And in some cases, you may use one or more of these methods depending upon what level of insight that you're trying to achieve. As I indicated on the example methodologies for the initial, the last slide of this slide deck has a number of references that you can gain more insight, more information with regard to these different methodologies. So let's talk about what is the relationship of the cyber risk assessment to an overall life cycle of an operating facility. If you think of a greenfield site, you're going to go through a capital project, and as part of the project specification and design phases, doing your risk assessment is a staple. Ultimately, that capital project will go into operation and exist for many, many years. And part of the life cycle is that you should periodically go back and revalidate your risk assessments after you've gained some level of experience during operation. Things change, the landscape, the threat landscape changes over time, so a series of periodic reviews is very appropriate. For those facilities that are regulated by process safety management regulations, they've got a requirement that you would do that every 5 years. You also have the situation today, in particular, where there's a lot of legacy sites, a lot of brownfields that exist that they've never done a risk assessment. They're really just, they've had IT cybersecurity programs, but they really haven't truly addressed cybersecurity down at the OT level to the extent that they could or should have. In those cases, what you need to do is you need to first gather your information, develop that information necessary to perform the various risk assessments that should be done, performing the initial risk assessment first because that's the least amount of information you need. That can help the effort get started. You also want to make sure that you've documented your RAGAGEP prior to the detailed cyber risk assessment. Once you've done all that, then you actually will perform your first detailed cybersecurity risk assessment, and now you're into the life cycle just as if it were a greenfield kind of thing, and you will periodically revalidate that on the same kind of basis. Cybersecurity requirements spec. You want to provide the baseline requirements for detailed design. You want to support, it can also use it to support competitive bidding. And it provides a baseline for management of change. If you're making a change and you have a documented basis of what you're supposed to have and why you're supposed to have it, then you can, your management of change will be that much stronger going forward. The guidance is to begin documenting that as part of the scope definition or specification phase of a capital project, and then finalize it after you've completed your detailed cybersecurity risk assessment. And as I said, it provides that foundation for detailed design with a documented design basis. Contents, you want all your requirements documented. It should be a consolidated version of all outputs of the hazard and risk analysis phase. Also, you can consider a full list of safety requirements as well as a full list of cybersecurity requirements for each zone and conduit, including all cybersecurity requirements from policies, regulations, and risk assessments, and consolidated with the above safety requirements. In the safety world, there's a thing called a safety requirement specification that is doing the same thing for safety that we're doing here for cybersecurity. The cybersecurity requirement may be part of the safety requirement specification, or it could be a standalone document. That's up to the individual companies, whatever works for them. The one thing that is important is if there are any contradictions identified between the cyber requirement specification and the safety requirement specification, they must be resolved so that you've got a fundamentally sound basis going forward. Here's the slide that I said, our last slide. Got the various references that you can look at to try to bone up on some of the methodologies. And with that, I believe we have some time to take some questions.
Indeed, we do. Thank you, Hal, for that great presentation. And to the audience, we are going to move into the Q&A session in a moment. So we do have some questions waiting for us right now. If you haven't submitted your question yet, you can do so now by entering it in the Q&A box and clicking Submit. We have about 10 minutes to answer questions, so we'll try to get through as many as we can. If we don't answer your question, we will follow up after the webinar. So please send in your questions and comments. In addition, I just want to call out a few folks that sent in some questions asking whether or not the content will be available to view again. Indeed, it will. The on-demand replay version of this webinar, including the Q&A session that we're about to go into, will be available an hour after the webinar ends today, and you can use the same link that you used to access. We also received a few thank yous to Hal, so we appreciate that. Thank you. We are glad that Hal's here with us as well. All right, so let's move into the Q&A session. So our first question from the audience: how can a company go about creating their own risk matrix? Hal? Okay,
my suggestion, this is a senior management activity. They're the ones who set policy, and I would direct you to that CCPS guideline on how to go about creating your risk criteria. That's really, I think, the preeminent resource out in industry today to go about doing that. But it's got to be a top-down exercise from senior management. And that reference is on the slide, one of those early slides. Next question.
Excellent. Thank you for that. Yes, absolutely. I just want to mention also, Hal just mentioned the slides. There are a few questions that I've already responded to, but for the greater audience, the slides are available in a PDF version. Along the bottom of your screen, you will click on the Resources tab, and then the PDF version will be available. So if you need to reference that slide that Hal mentioned or any of the other slides, please feel free to access that at any time. Okay, next question from the audience. Can you elaborate on defense in depth?
Yeah, as I said, when people throw that term defense in depth out a lot, and a lot of people seem to think that it's simply putting a firewall between each level in the Purdue diagram, and that couldn't be further from the truth. First off, every Purdue level in the model is not really a zone per se. Some of your zones can and should go across various levels. I mentioned the cyber kill chain, and the phases that an attacker typically would have to go through to execute a successful attack would be reconnaissance, weaponization, delivery, exploitation, installation, command and control, actions on objectives. And if you break the chain at any point, they will not be able to get to actions on objectives. Okay? So the trick here is to identify those countermeasures that are associated or that can be used to prevent the various phases. Certainly, preventing reconnaissance is probably the most difficult, but also if they don't proceed beyond that stage, it's sort of like no harm, no foul. But you identify the countermeasures that you can employ. As I said, some of them are specific to a phase, some of them are effective against multiple phases. And if you've actually provided depth and breadth of protection across the entire kill chain, then you have achieved defense in depth. Segmentation, firewalls, those are countermeasures that are effective for some phases. They're effective, let's say, for external people, potentially, external attackers. But a firewall, for instance, is not going to be effective if your threat agent is actually attacking from within, that it's an inside disgruntled employee or a malicious insider. If you think of the Stuxnet virus that took out the Iranian centrifuges, that was a USB stick plugged into the network, or into a device, one of the control devices. And, it basically bypassed the firewall. So that's why you've got to look more deeply at the defense in depth. With regard to what countermeasures, there has been some work documented. I can refer you to Technical Report 84.00.09, the second edition. One of their annexes contains typical countermeasures, and some of those countermeasures are documented as a function of the kill chain phases. I hope that annex will be substantially upgraded as we continue to proceed with the third edition work. Okay, next question.
All right, thank you for that. Yes, so next question from the audience. Okay, here we go. What is the timing of the risk assessments?
Okay. The pat answer is as early as possible. You should be doing the initial risk assessment as soon as you know what types of devices that you're going to be specifying for a capital project. One might argue the only thing that would prevent you from doing that is as soon as you understand what your significant consequences can be resulting from loss of control, that's when you want to do that initial risk assessment. The detailed level risk assessment is going to require a certain amount of front-end engineering work to be done. But as soon as you start getting that scope put together, you want to be trying to do that detailed level risk assessment, once again, as soon as possible. And the reason for that is that everybody, when I worked in industry for an end user, all the operations folks would say, we don't have that information yet. We'll get to it. And then you end up doing the risk assessment after the plant is, let's say 3/4 of the way through detailed design. And if that's when you do it, changes are very, very expensive. So you want it in the capital project work process at a point where you haven't overly committed to your detailed design so that you can manage the impact that changes are going to have. Because when you go in and you look for flaws, you're going to find some. And when you find some, you want to be able to fix those flaws as inexpensively as possible. And that means doing it as early as you can. With regard to once you're in operation, there's two things. One, you'll typically set an interval, and I sort of talked about process safety management regulations saying no greater than 5 years. Some argue that because cyber is so dynamic and evolving that it should be done more frequently, but yet there's no standards out there that provide any guidance as to the actual timing. So I'm content with the 5 years as long as you also have in your policies and procedures that, based upon experience, if you have some incidents that would indicate that the assumptions that you made in your original risk assessment were not valid, or some significant new vulnerabilities, that there would be a mechanism to short-circuit the defined frequency and do it based upon, think of it as condition-based maintenance, analogous to that. I think that answers that question.
Excellent. Thank you, Hal. And we actually just ran over time. We're going over by a couple minutes. So we're going to move to close now. Again, Hal, thank you so much for that great presentation and taking the time to answer some questions. And I know you'll help us out in answering some of those questions that we weren't able to get to and provide answers to the audience. So to the full audience, again, we apologize we weren't able to answer your question during today's session, but we will reach out after the webinar. So thank you so much for sending those questions and comments, and we really do appreciate it. So we're going to close the webinar now. So again, thank you for attending. You will all be receiving an email from us with a link to the on-demand version of this presentation, so you will be able to come back and watch this again or share it with your colleagues. And lastly, please take a moment to complete a survey, which will appear on your screen at the end of this live webinar. For on-demand viewers, you will find the survey located along the bottom of your attendee console in the survey widget. Again, thank you for taking the time to attend this webinar event. Take care, and we will talk with you soon.